Two audio speakers are kept some distance apart and are driven by the same amplifier system. A person sitting at a place 6 meters from one of the speakers and 6.4 meters from the other. If the sound signal is continuously varied from 500 Hz to 5000 Hz, what are the frequencies for which there is a destructive interference at the place of the listener? Speed of the sound in air is 320 meters per second. Fine. Now let's say this is one of the source and this is the another. This is the place where the listener is sitting. So this distance is given as 6 meters. The another distance from the speaker is 6.4 meters. So one thing is pretty clear, that the part difference is simply 6.4 minus 6, that comes out to be 0.4 meters. This is the part difference of the two waves that is coming at the ear of the listener from A as well as B. Fine. Now the second thing is, we know that part difference for destructive interference should be equals to n plus 1 by 2 times of wavelength. Fine. And we know that wavelength is given by wave velocity divided by frequency. Right. This is the frequency and this is the wave velocity. So substituting the value of lambda over here, so the part difference, that is 0.4, should be equal to n plus 1 by 2 times of wave velocity, that is 320, divided by frequency. Fine. Now what I have to do is, I'll substitute the value of n as 1, 2, 3 and 4 and 5 and so on, and I'll get the respective values of frequency, and those frequency will cause destructive interference which be lying between 500 Hz to 5000 Hz. That is pretty simple, right? So nu comes out to be 2n plus 1 by 2 into 0.4 into 320. So if I substitute the value of n is equal to 1, then the frequency will be 3 by 2 into 0.4 into 320. So that is something near about 3 into 3200 by 2 into 8, 2 into 4, so it will be 3 by 2 into 800, that is 1200 Hz. So similarly, just go on substituting the value of n is equal to 2, 3, 4 and 5 until you get the frequency less than 5100. So if you substitute the value of n equal to 2, 3, 4 and 5, you get the frequency as 2000 Hz for 2, then 2800 Hz, 3600 Hz and 4400 Hz. Right, you get the destructive interference for the frequencies that are above 4400 also, but the point is that the signal is continuously varied from 500 to 5000, so you have to restrict the frequencies between these two frequencies only, right? So this is your answer.